Constant rule. A constant rule states that the derivative of a constant function is zero, which means that all constant will be equal to zero. We have this one example, which is y is equal to 16. Since we need to put or, the answer will be 0. The derivative of y, which is y prime, is equals to 0. So next example is f of x is equal to 10. Just like the first example, we will need to put it in 0 or the answer will be 0. So the prime of x is equal to 0. Now let's use the definition of derivative. We know that the prime of x approaches to 0. So we will use the equation, which is f of x is equal to lim approaches to 0. f of x plus h minus f of x over h. So since 10 is our example, we will put it in lim 10 minus 10 over h approaches to 0. So the answer will be 10 minus 10 is equal to 0 over h. Then the answer we will get is 0.
So in this example, here we have the derivative with respect 10x to the 6th power. Our first step, bring this constant outside of our derivative. 10 times the derivative with respect 10x of the 6. So we can use the power rule to determine what this derivative is equal to here. And so we bring down the exponent, so we have times 6x, and then we're going to subtract 1 from our exponent. So 6 minus 1 is equal to 5, and so we have 60x raised to 5.
The derivative of a sum is equal to the sum of the derivative. Here is an example. F of x equals to 48x cubed minus 27x squared plus 15x. The derivative of the function with respect to the variable x. The constant times to a function is the constant. Derivatives ng x cubed is 3x. 3 minus 1. Minus the constant times to a function is the constant. Derivatives ng x squared is 2x. Plus 15 times 1. Then simplify. 48 3x 3 minus 1 is 2 minus 27 times 2x 2 minus 1 is 1. Pwede hindi na natin ilagay yung 1. Plus 15 times 1 is 15. Forty-eight times 3 is 144. X squared. Minus 27 times 2 is 54. Plus 15. And here's the answer.
Today, we'll be learning how to use the product rule to find the derivative of a product of two functions. But first, what is the product rule? The product rule is a formula used in calculus to find the derivative of a product of two functions. If you have two functions, u of x and v of x, the product rule states that the derivative of their product is given by u dv plus v du. Let's have an example. Let's use 4x minus 3 multiplied by 2x plus 5. Let u be the first function, 4x minus 3, and let v be the second function, 2x plus 5. Now, let's find the derivative of u and v. Derivative of 4x minus 3 is 4, and the derivative of 2x plus 5 is 2. After finding all the variables, we can now proceed with substitution. u dv plus v du. u equals to 4x minus 3 multiplied by dv, which is 2, plus v, which is 2x plus 5 multiplied by du, which is 4. Now we can proceed with the solving. 4x multiplied by 2, 8x. Negative 3 times 2, negative 6. Copy the additional sign. Then 2x plus 5 multiplied by 4 equals to 8x plus 20. Now arrange it in order. 8x plus 8x plus 20 minus 6. Then solve 8x plus 8x, 16x, plus 20 minus 6, 14. And our final answer is 16x plus 14. After the product rule, I'm now going to explain the quotient rule for differentiation. The quotient rule is used to differentiate functions that are divided by each other. In quotient rule, we use the formula v du minus u dv all over b squared. Let's use x squared plus 3 over 5x plus 4 as an example. Let our numerator x squared plus 3 as u and let our denominator 5x plus 4 as v. After finding the u and v, we can now proceed by finding their derivatives. The derivative of x squared plus 3 is 2x and the derivative of 5x plus 4 is 5. After finding all the variables, we can now proceed by substituting. V or 5x plus 4 multiplied by du or 2x minus u or x squared plus 3 multiplied by dv or 5 all over v or 5x plus 4 squared. After substituting, we can now solve. 5x multiplied by 2x is equals to 10x squared plus 4 multiplied by 2x, 8x. Copy the negative sign or the minus sign. X squared multiplied by 5, 5x squared. Positive 3 multiplied by 5, positive 15. Copy the denominator 5x plus 4 squared. After that, let's distribute the negative sign or the minus sign. Negative times positive 5x squared. Negative 5x squared. Negative times positive 15, negative 15. After distributing the negative sign, we can now proceed by arranging. 10x squared minus 5x squared plus 10x minus 15, then copy the denominator 5x plus 4 squared. After that, we can now combine like terms. 10x squared minus 5x squared, 5x squared. Now, since there are no more like terms to combine, our final answer is 5x squared plus 8x minus 15 all over 5x plus 4 squared.
Now let's move on to trigonometric function. Let's think first. Let's find the derivative of trigonometric function. First thing first, let's find the derivative of sine x is equal to cosine x. Derivative of cosine x is equal to negative sine x. Derivative of cotangent x is equal to negative cosecant squared x. Derivative of tangent x is equal to secant squared x. Derivative of secant x is equal to secant x tangent x. Derivative of a cosecant x is equal to negative cosecant x cotangent x. Now let's move on to the example. Let's find the derivative of sine x 4x cube. Now let's find the derivative of this. Y prime is equal to cosec cosine cosine no cosine 4x cube, then multiply by this, the derivative of this x, derivative of 4x cubed y prime is equal to cosine 4x cubed multiplied by derivative of this is 4 times 3 is it's 12x, then this pag maminusan lang natin siya ng isa magiging equal to, then let's multiply this function. Cosine multiplied by 12x squared is equal to 12x squared cosine by 4x cubed. Now this is the final answer. Now let's move on to the next example. Y is equal to cosine 3x plus 4. Then y prime is equal to cosine the, the derivative of cosine is negative sine of 3x plus 4 multiplied by the derivative of 3x plus 4. Y prime is equal to negative sine of 3x plus 4 multiplied by 3, because the derivative of 3x is 3, derivative of constant is equal to 0. Now let's multiply this. Y prime is equal to negative sine multiplied by 3 is equal to negative 3 sine of 3x plus 4. Now this is the final answer. Now let's move on to the third example. Y is equal to tangent of 4x minus 2. Now let's solve this. Y prime is equal to derivative of tangent is secant squared of 4x minus 2 multiplied by the derivative of this function is 4x minus 2. Y prime is equal to secant of 4x minus 2 multiplied by the derivative of this 4. Now let's multiply this and this. Y prime is equal to secant squared multiplied by 4 is 4 secant squared of 4x minus 2. Now this is the final answer. Now let's move on to the next example. Y is equal to secant x plus 3 cosecant x. What about this? Y prime is equal to, let's find the derivative of secant x. The derivative of secant x is secant x tangent x plus 3, then multiply by the derivative of cosine is equal to negative cosecant x and cotangent x. Now let's multiply this number and copy this secant x tangent x multiply by of negative cosecant x cotangent x multiply by 3. positive times negative, negative, copy this 3, then copy this equation, cosecant x, cotangent x. Now, this is the final answer of the problem. So, let's move on for the
Hello everyone. Today, in my part, we will talk about the derivatives of exponential functions. This is an important concept in calculus that is often used in math and science. We're also going to look at an example to make everything clear. What is the exponential function and its derivative? An exponential function is a type of function written as f of x is equals to a raised to u of x, where a is a constant number like 2 or 3, where u of x is a function of x like 3x raised to 2, and where u prime of x is the derivative or the rate of change of u of x. Here is the formula of the exponential function. F prime of x is equals to a raised to u of x multiplied to ln of a multiplied to u prime of x. Now let's understand how to find the given example, or the derivative of f of x is equals to raised to 3x squared. So the first one is we need to understand the function. The function f of x represents a number raised to the power of another function. In this case, the base is 2 and the exponent is 3x raised to the power of 2. Second, we need to find the change rate. To find how fast f of x changes as x changes, we need to find its derivative. We start by identifying the parts, which is a is equals to 2 and u of x is equals to 3x raised to 2. The third one, we need to find the rate of change of u of x with respect to x, which is u prime of x. Now we have to find the derivative of the given u of x, which is 3x raised to 2. To find its derivative, we need to multiply the constant 3 and the exponent 2. So 3 times 2 is equals to 6. Then we need to minus 1 on the exponent. So we will get the answer u prime of x is equals to 6x. And the fourth one, we need to apply the formula. Using the formula for the derivative of an exponential function, f prime of x is equals to a raised to u of x times ln of a times u prime of x. We then plug in the values we found, which is a is equals to 2 and u prime of x is equals to 6x. The fifth one, we need to calculate the derivative. After substituting the values, we get f prime of x is equals to 6x multiplied to 2 raised to 3x raised to 2 multiplied to ln of 2. This is the derivative of f of x, which tells us the rate of change of f of x at any point of x. So in simple terms, we found how fast the function f of x changes with respect to x using derivatives.